Okay, so now we'll start to discuss consumer budget limitations. We know that we would just like to purchase more of everything because more is better, and by doing that, we could get ourselves to a higher utility curve, but usually we're going to be constrained by some sort of limited income and the prices of goods. Right, the budget constraint is going to show us the trade-off that the consumer faces between purchasing one good or another. So we can write the budget line. In the previous graph, we had food on the x-axis. So we have the price of food times how much food you have, plus the price of clothing, the y variable, times how much clothing you have equals your income I. All right, or in a more general case, we have pxx plus pyy equals your income I. Right. What this budget constraint is going to show us is if we have a particular budget, what are all of the possible combinations of goods that we can purchase? So suppose our income is I and the price of food is $1, price of clothing is $2. This table is showing us is a bunch of different combinations that are all on the same budget line, all add up to $80. And one thing that's important to note is that in this simple model, we don't have any use for savings. So we're going to assume that if the consumer has income, they're better off spending it on goods. We know in the real world that that's not true. There are reasons that you would want to save or perhaps invest. For now, we're simply looking at consumer choices between purchasing a couple of goods. All right, so graphically, what does this budget line look like? So again, we're going to consider the case to start with where we have a consumer income of $80, the price of food is 1, and the price of clothing is 2. So again, the budget line shows us what are all of the possible combinations of goods that we can purchase with, in this case, $80. So if we wanted to graph a budget line, we know it's going to be linear as long as the prices aren't changing, and we're not going to look at any cases of changing prices. So budget constraint or budget line will always be linear. And in order to graph it, we can ask ourselves, okay, here's clothing on the y-axis. So the y-intercept of this budget line is going to be a point at which we buy 0 food. Right? If we only buy clothing, how much clothing can we buy? We have $80. The price of clothing is 2. So if we spend all of our money on clothing, we can buy 40 of them. All right. And once again, you could just plot out a bunch of points, B, D, E, and so on, and connect them. I'm recommending if you're plotting out a budget line, you just look at the intercepts because those are easy to calculate. Here we calculate if we spend all of our money on clothes, how much clothes do we buy? Our income over the price of clothing. This intercept, our x-intercept, is going to be we buy 0 clothing and spend all of our money on food. How much food can we buy? The price of food is 1. We have $80, so we can buy 80 of them, I over PF. All right, just like MRS being the slope of the indifference curve, we want to consider the slope of this budget constraint. The slope is rise over run, and it's negatively sloped. So our rise is 40, our run is 80, our slope here is -1/2. In a more general case, we have our rise would be I over PC, our run I over PF. So if you divide I over PC divided by I over PF, you're going to get negative PF over PC because dividing by a fraction flips the fraction and then you multiply. Okay, or more in general, the slope of this budget line is going to be negative px over py, negative px over py. So that's what we have here. Okay, what about changes to the budget line? Suppose we get more or less income. Here's our original budget line of 80. If we only have $40, then here's a line which shows us all of the combinations we can buy with our $40 income, given the same prices. If we have $160, here's L2, which shows us all of the combinations of goods we can purchase with our $160 income. So changes in income without changing any prices are going to be parallel shifts of this budget constraint. And then, of course, what about if prices of individual goods increase or decrease? So here we're showing changes in the price of food. Originally, food cost $1, right? If we don't change our income stays at 80, and the price of food goes up to 2. We can still buy the same amount of clothing. We have $80 to spend. The price of clothing is 2, but we can buy less food. The price of food has gone up, so we can only buy 40 at the new price of 2. Or if the price of food has gone down, once again, it doesn't change the maximum number of clothing we can purchase. It rotates us out here, so now we can buy more food with the same amount of income. All right, so that's it for this video. Please get a hold of me if you have any questions.